Good morning, good afternoon, and good evening, colleagues. Dear participants, welcome from the Secretariat of the Convention on Biological Diversity. My name is Frédéric Vogel. I'm joined here in Montreal by my colleague Jessie Monnier, and online we have Abhinav Prakash and Eric Tamale from the Secretariat. Thank you for joining us today for the 7th webinar of the Knowledge Management for Biodiversity Initiative. This series has started with presentations addressing biodiversity knowledge management at the global, regional, and then the national levels. Indeed, a couple of weeks ago, before the Substar 25 break that took place last week in Nairobi, we have heard from South African colleagues who introduced us to the way the South African National Biodiversity Institute, SANBI, tackles biodiversity knowledge across their organization and the country. Their presentation highlighted that effective knowledge management requires equal focus on people, products, and processes. For those who are interested to view or review the recordings, summaries, and presentations, please head to our website, km4b.cbd.int. Today, we will hear from two authoritative organizations that tackle biodiversity issues at the regional and global level. Both have been playing a leading role in the Biodiversity Observation Network for over a decade, with a mission to improve the acquisition and delivery of biodiversity information to users, and in particular, to decision makers. The theme of today's presentation is knowledge management for conservation and restoration success, and both presentations will address the role of biodiversity knowledge networks and communities of practice in facilitating effective knowledge management. Before we dive into their presentations, let me just inform you that the chat and question and answer function are open to everyone to ask questions to panelists and exchange with other participants. The buttons to address and ask you questions are at the bottom of your Zoom user interface. So without further ado, let me introduce you to our first presenter, Hiroyuki Muraoka, who will present the Asia Pacific Biodiversity Observation Network, AP-BON. Mr. Muraoka is professor at the Gifu University in Japan and the co-chair of the AP-BON. Professor Muraoka, the floor is yours.
Thank you very much for introducing, and good morning, good afternoon, good evening, ladies and gentlemen, wherever you are. So let me share my screen. So today I would like to, as already introduced, kindly introduced by Frederick, I would like to introduce some activities and outcomes and some challenges that the Asia Pacific Biodiversity Observation Network have been done or is going to do. So my name is Hiroyuki Muraoka from Japan, and I am one of the co-chairs of the AP-BON, and other co-chairs are from Thailand and Malaysia. So maybe many of you already know that the Asia-Oceania region is characterized by many diverse characteristics, including the complex geographic characteristics, large populations of the world, drastic climate change, natural disasters occur frequently, and rapid and diverse socio-economic development, and deteriorating ecosystems. As you know, that many biodiversity hotspots are distributed in our region, and we have the high biodiversity, terrestrial, freshwater, coastal, and marine, but its loss is in progress. And also, our region is characterized by diversity of ecosystems and functions and services like environmental regulation and provide goods and services. So the challenges in our region and also maybe globally, that biodiversity loss is proceeding, and the question is that we need a more deeper understanding and some addressing the interlinkages of climate, biodiversity, and ecosystem functions. Excuse me. So having these challenges in the climate change biodiversity losses. In 2008, the GeoBond was established, and then responding to the establishment of the GeoBond, the Japanese scientists, particularly for the biodiversity science, established the Japan Biodiversity Observation Network called JBON by the support of the Ministry of the Environment Japan. And by having this JBON as the basis, we established the AP-BON to have a more regional cooperation mechanisms and also the collaborative research, data sharing, knowledge management, and capacity development. So AP-BON was established in 2009, already more than 10 years ago. The missions were a contribution to the sound decision making related to biodiversity conservation based on scientific information, facilitation of the utilization of existing biodiversity data, and coordination of a regional network to exchange the data, knowledge, and also building the capacities. So activities involved monitoring the changes of biodiversity, like doing some biodiversity mapping, identification of key drivers like land use change, climate change, and networking of the observation networks for sharing information through the networks, and the capacity buildings. And so far, we have many contributors from Japan, China, Korea, Thailand, Malaysia, Cambodia, Philippines, and also ASEAN Center for Biodiversity, Nepal, ICMOD, USA, Australia, and Indonesia. And AP-BON was designed to try to connect the in-situ biodiversity observations and ecosystem observations, and then Earth observations. And after 10 years of the AP-BON activities, we had some review of our outputs for the past 10 years. Then we updated our work plan toward 2030. So again, we still have the same AP-BON's missions, but we are trying to promote more linkages with decision makers or practitioners or the citizen sciences, not only for the academia, but also those many kinds of stakeholders in our subnational or national or regional scales. So let me introduce you some highlights from AP-BON. So we have some activities like trying to promote the monitoring of biodiversity, like the mapping tropical tree species and changes in forest cover or protected areas in the Hindu Kush Himalaya, and assessing the threat and priorities in the regional scale, and mapping bats and zoonoses. Also, mobilizing biodiversity data is also important activities, and we are trying to deliver this data and knowledge into the conservation practices. So these are some examples from the collaborative research from the AP-BON. We have many observation plots in East and Southeast Asian countries. So, for example, our Japanese colleagues have been monitoring the plant species biodiversity and recording new species in Southeast Asia. We still have new species or unfounded new species. And our colleagues from Coastal and Marine Working Group try to map the ecologically and biologically significant areas for coastal biodiversity. And our colleagues from Freshwater Working Group try to evaluate the fish diversity and its impacts by climate change and dam construction in Mekong River. And just recently, another colleague is developing a three-dimensional digital database like FFish Asia or Afrolasia that are using the very advanced technology of the AI and other imageries. From Thailand, our colleagues, that Professor Younger Trisrat he is also the APMO co-chair. His group has been concentrating or investing their efforts to the biodiversity monitoring and structuring database. And as you can see on this slide, they developed the digital atlas of trees and wildlife in Thailand. Based on the data and knowledge, they are trying to deliver these findings into the Thailand's CBD Kumi Montreal GBF 30 by 30 assessment or evaluations. We have a very good partnership with ASEAN Center for Biodiversity based in the Philippines, and they are, of course, as you may know, and I know that the representative from the ASEAN Center for Biodiversity presented their activities in the past seminar of this series, that in a people concept context, they are doing these capacity building activities like the data mobilizations and trainings of the data mobilizations or knowledge productions. And from Nepal, ISIMOD, this is led by Dr. Sunita Chaudhary, that her team had been doing very great efforts for monitoring and capacity building and data sharing in the Hindu Kush Himalaya region. For example, along the altitudinal gradients, they are monitoring the biodiversity and ecosystem structures like the tree growth. As a capacity building activities, they are doing some data analysis, data mobilization training courses for the next generation scientists. These are just some examples from the APBON members, and many of the data and knowledge sharing have been done by the database and publications from the APBON. For example, the APBON knowledge sharing has been doing by our APBON website by sharing the presentation files or publications from the journals or the workshops, webinars. And ASEAN Center for Biodiversity has their dashboard. And our APBON secretary at the Biodiversity Center of Japan has their own biodiversity databases that contains many long-term biodiversity observation data and knowledge in the Japan national landscape observations. And Fish Asia, that this is the, again, the three-dimensional databases. We have been publishing many books, contributed to the CBD Technical Series Report, IPBES Regional Assessment Report, and many data sharing have been done by the data papers, etc. Also, we in the last 3 years, during the COVID-19 pandemic, we didn't have a chance to see each other. So far, we had once or twice per year, we had an in-person workshop or symposia to exchange our knowledge and also ideas. But in this recent 3 years, we attempted to continue our communication through the webinars, seminars. Then, as you can see, we had a lot of seminars in the last 3 years, and all these informations, that presentation files or data are always shared on the APBON website as a database or knowledge base of our activities. So you are also welcome to try to access our APBON website. The information will be shown at my last slide later. Then you can see all these presentation files. And currently, APBON is trying to assess the data and observation needs or availability or accessibility of the existing data and knowledge. Through this assessment, we are trying to identify the data and knowledge gaps, and then try to design the observations, aligning with EV breeds, encouraging development of national bonds and regional one of the important role of our regional cooperation is to try to engage with each country's scientists or stakeholders, and then try to help develop their own national bonds, and then have our regional cooperation. So AP bond has been paying efforts to have enhance their networks. On this figure, you can see the logos of AP bond and also the AP Marine bond, which is under the Marine bond network. And having this AP bond and AP bond, we have a good network with the GeoBond, of course, and under the GeoBond, we have the network with the freshwater bond and marine bond. And then we have the national bonds like the J-bond, Korea bond, Sino bond, and Nepal bond, and others. And maybe you now see, you're seeing the logos of the Geo or AO Geo or Japan Geo. I will talk a bit later, talk about this later, but AP bond has been developed with the cooperation with the GEOS Asia Pacific Symposium to develop the community with the regional stakeholders, or not only with the biodiversity science community, but with other Earth observation communities. So let me introduce some about the AOGEO, Asia Oceania Group on Earth Observation. This is one of the regional GEOs of the, GEO is a group on Earth observation, and AOGEO is one of the regional GEOs. And as you can see, Asia Pacific Biodiversity Observation Network is one of the task groups of the AOGEO. And not only about the AO, and this is not the very short history, but from the beginning of the AP bond, we had the very good cooperation or collaboration with the GEOS Asia Pacific Symposia, or we call it now AOGEO Symposium. As you can see on this table from 2009, every year we had a very good back-to-back events, symposia, or some workshop with the GEOS Asia Pacific or AOGEO communities. And another important aspect that networking with Earth observations community is to try to network the in-situ research networks in our region. For example, we have the AP bond at the left top hand side, and 3 other networks are involved, including CO2 Flux and Greenhouse Gas Research Network called Asia Flux or OzFlux. And then we have the Long-Term Ecological Research Network we call International LTR Network or the National Networks, of course. And then we have the partner networks like In-situ Remote Sensing Observation Networks. So all these networks have somewhat different academic or scientific backgrounds like biodiversity or micrometeorology and greenhouse gases, long-term ecological research or remote sensing. But having the network of networks concept, we would try to have more cross-disciplinary, cross-scale observations throughout the region. And just recently, we had a very good conversation with the AOGEO community. And we have been discussing or considering that not only about observations, but these observations, data, and integrated analysis, and producing some intelligence for addressing the environmental issues by delivering the data, knowledge, intelligence to the stakeholders are quite important, as all of you may understand. So last year and 2 years ago at the AOGEO Symposium, we had a special session that focusing on this, producing some value chain from Earth observations, integration or analysis, evaluation, and the utilization. Then not only about this one-way kind of value delivery, but we are thinking that if we could enhance by cooperative activities with the stakeholders or data and knowledge users, maybe we could have the very good value chain as presented in this figure. if our observation data, knowledge are quite useful for the society, then the society would help the observation community to promote more observations and data and knowledge promotion and management. So finally, we have some, I just listed some needs and challenges to connect the observations and society. So we need more broader understanding about the multiple dimensions of biodiversity and ecosystem data. And integrative research is quite important. We need more interdisciplinary research and understanding on climate, biodiversity, ecosystem functions across scales. Then cross-scale observations and also filling the observation gaps are important. Of course, we need open science, not saying about the data sharing, but we want to produce the interdisciplinary knowledge or Earth intelligence to try to address the environmental issues. To do that, we need a promoting value chains from Earth observation, analysis, evaluation, intelligence, and decision making. This is kind of science to action scheme, and this could be promoted by networking networks and stakeholders. So thank you very much for your attention, and you are all welcome to try to access the AP-BON website, on which we have many presentation files or some information of the activities of the AP-BON and some biodiversity data and knowledge in our region. Thank you very much.
Professor Muraoka, for a very detailed presentation. I've seen a few questions popping in already and a few greetings from all over the globe. I can see from India, from our very own Canada region in far north, and even from the Asia region. And I know it's late for our dear colleagues joining from there. And thank you, Professor. I know it's already late in Japan. Thank you for being able to present.
Thank you very much.
You're welcome. And allow me now to introduce you to our second presenter, which is Professor Henrique Miguel Pereira. Professor Pereira is affiliated to the Martin Luther, it's a different person, University Halle-Wittenberg. He is member of the speaker board of the German Center for Integrative Biodiversity Research, IDIV. And when I was looking for the I in IDIV, it's integrated research. And so I can see you share both in AP-BON and here in IDIV the same concern. So from 2013 to 2020, Professor Pereira was the chair of the GeoBON, and he currently leads the EuropoBON project. He will introduce us to the work of IDIV, who is actively participating in many international policy development fora, including the IPBES and the Convention on Biological Diversity. Professor Pereira, you have the floor.
Thank you. And I'll say, based on the chat, this is good morning to some, good afternoon to others, and good evening to others. This is the wonder of having the possibility of doing these video conferences now, where we can all participate without not only paying the cost of the travel, but with a very low carbon footprint, what is also very, very important. And I wanted to follow up on the previous presentation with a bit the experience of the EuropoBON, that is the equivalent of AP-BON for Europe. But before, as I was asked to share a bit of the work in IDIV, more generally, I wanted to make some comments on some of the other work that we have been doing here at IDIV. So let me start by something that you all know, is the timeline of biodiversity targets under the Convention on Biological Diversity. So the convention was opened for signature in 1992 in the Rio meeting. Around 2002, we had the 2010 goal established that said achieve by 2010 a significant reduction of the current rate of biodiversity loss. In 2010, we failed that goal, and a goal for 2020 was established, or in reality, a set of 20 goals for 2020, the so-called Aichi targets. Those goals were assessed in the Global Biodiversity Outlook 5, partially based on the IPBES global assessment, and again, we failed to meet in its entirety all the targets, although some of the targets we met partially. And this led to the post-2020 framework that was adopted in the so-called Kunming-Montreal framework, Global Biodiversity Framework, that now has a new set of goals and targets that we are now trying to implement as we head to 2030. That's the first big milestone of the framework. And at the same time this is happening, of course, biodiversity is declining. This is a couple of analyses here, one in the showing the decline in global species richness, so the global extinctions, the top left. The top right is an analysis of areas where we have lost biodiversity, and red means areas we lost biodiversity in the last 100 years, a lot of areas. And in the bottom, you have the LPI index, also suggests declines in population. So this is what's going on at the same time we are setting these targets. So one can ask, okay, we have been setting these targets, why haven't we reached past biodiversity targets? And a couple of years ago, I had the pleasure to collaborate with Hagen Shu and colleagues in an analysis of this question that we published in Nature, Ecology and Evolution. And we've identified 5 types of issues. Inadequate national policy responses, so that in reality, the national biodiversity strategies are not sufficiently aligned with the global strategies. Funding shortages, this is a real issue in much of the world, including in some of the richer countries. The resources for biodiversity are not sufficient. There's also knowledge gaps at the science policy interface. So sometimes the policy goals are say an ambition, but the science to fulfill that ambition may not be there. And then there is imperfect review mechanisms in terms of assessing how much progress there has been towards goals. There was very limited, let's say, tools for that in the past. Now we have the monitoring framework of the Global Biodiversity Framework, and that's a step forward. But as those of you involved in the monitoring framework can probably agree, we're still very far from having really an excellent review mechanism and monitoring and assessment mechanism for the implementation of the Global Biodiversity Framework. So really there is this huge gap between the goals and the implementation of the goals that is linked to these reasons. And we have been thinking about how to have science better support these goals, and we published a little paper about that a couple of years ago in Conservation Letters, saying that to develop effective implementation of the GBF, we need to identify the actions that need to be taken, and this needs to be done with different stakeholders, with ownership of the different stakeholders, and it needs to be in much more detail than what we have in the, let's say, the general targets of the 2030 the traditional targets is too generic to identify these actions. We have to do this exercise in the different countries, in the different at different scales and with different stakeholders. We have to implement those actions through mainstreaming. This is the responsibility of addressing the biodiversity crisis is not only in the ministries of environment. In reality, it's a problem that is cross-cutting across many ministries, and it's one of the challenges we have is to working with the different sectors of government and of the economy in implementing these actions. And then we have to assess progress and have accountability mechanisms that reward actors and countries that make more progress, and that penalize those actors that are not making sufficient contributions or sufficient actions to address the crisis. And then we have to adapt. This is an iterative cycle, and eventually refine the actions or identify new actions to meet the targets. And in order to do these 3 steps of the of this framework for implementation post 2020, we need to use the most recent science, the best science available for this, the best biodiversity science, the best integrative biodiversity research we have available. And there has been a lot of developments in the last few years in biodiversity research that we have organized here in 5 major topics: multiple values of biodiversity, remote responsibility, so who's doing what in relation to biodiversity elsewhere, teleconnections, for instance, restoration of biodiversity, how best to do restoration, how to have positive futures and scenarios for biodiversity, how to address the multidimensionality of biodiversity change, and how to do monitoring and modeling. I'm going to highlight a few of them, and then I'm going to develop much more the monitoring, because that's where I find that the strongest needs are in the coming years. So in multiple values, I think it's very important. We just had the IPBES just published a very nice assessment on values of biodiversity. And it's important to recognize there is much more diversity of values than maybe we recognized a few years ago. Besides intrinsic utilitarian values, we have relational values, and different stakeholders, all stakeholders, let's say, have multiple values for biodiversity, but the exact things that we value may be different across different stakeholders. And we have to be able to integrate these multiple values, including from, for instance, the urban communities and the rural communities. Different actors like resource users, fishermen, hunters, and for instance, conservationists. We have to be able to recognize that all of these actors have different values, and we have to have tools to get a dialogue about how to find common ground across the different actors. So we call this biodiversity democracy, when we bring these actors together to discuss the values and agree on common principles for nature conservation. In terms of positive futures, we have been doing a lot of work also in the context of IPBES on developing a new generation of scenarios called the nature futures scenarios, that has elicited positive visions for the future of nature and people with communities around the world. And you can find out more in, for instance, this publication, People and Nature, but there's many other. If you just do a Google Scholar search in nature futures, there is a lot of work now in doing this, including a big modeling initiative that we are now starting here at IDIV to model global scenarios based on nature futures. In restoration here at IDIV, we have emphasized rewilding research, this idea of letting nature manage itself, giving space for nature and allowing for natural processes, ecosystem processes, to be to run undisturbed by human management. I think rewilding has a big potential all over the world to do large-scale restoration, because a lot of the restoration that we see discussed sometimes is active restoration that requires a lot of human management and human interventions, and it's very hard to do the scaling up of that restoration to the skills that we need globally, where we are talking about restoring 20-30% of the area of the planet, and then for that kind of scaling up, it's very difficult to do that with that active restoration. So rewilding has some potential there. And finally, in remote responsibility, we have been looking at how we can assess the regions where the impact occurs from activities, economic activities that are driven by consumption elsewhere. And we have worked in interdisciplinary teams with economists, geographers, and biologists to do that. And for instance, to find that at least 25% of the impacts are mediated on biodiversity worldwide, mediated by global trade, maybe more. And now leading to biodiversity monitoring, one of the things that became apparent from studies in the last few years, biodiversity change is much more complex than what we thought about 20, 30 years ago. When the CBD was created, a lot of the emphasis was on extinctions, on species extinctions. And since then, we have come to realize that there's a lot of aspects of biodiversity that are changing. And this includes, for instance, the biomass of organisms. There is now a big concern about declines of biomass of insects, this so-called insect Armageddon. There is concerns about the declines of abundant species. Who would say that 30 years ago, that we would be, at that time we were worried about threatened species, rare species. Now there is concern about declines of common birds, both in Europe, for instance, in North America, but also in other parts of the world. And so we have a much more complex view of biodiversity change. And for that, we need better monitoring. We need to have much better monitoring of what's happening to really be able to have policies. And that monitoring needs to make the best use of existing data and use different sources like in situ observations, remote sensing, and models to really produce the best indicators and support development of scenarios that can inform policymakers. And that's what I'm going to talk in the next few minutes, is about an initiative here to address this problem from a point of view of an European biodiversity observation network. So to summarize, the problem is biodiversity change as complex spatial scaling patterns and temporal dynamics. Biodiversity monitoring is still very sparse in time and space and covers only some taxa. And there is limited resources for monitoring. We'll never have all the resources for monitoring that we'd like. Some studies suggest that in some cases, monitoring already takes up a big proportion of conservation budgets. It's, of course, not reasonable to have all the conservation budgets taken by monitoring. You have to also have some funding to do the conservation actions themselves. So the solution is really, as IPBES suggested in an assessment a few years ago, to integrate available data from multiple sources and target new monitoring schemes by using biodiversity models. And in Europe, we have a very nice mechanism to engage the scientific community in these kind of grand challenges that are the Horizon projects. The Horizon projects are calls done by the European Commission, and that is, let's say, the European government. In the European government, there is two agencies for research. There is one more directed to basic research that funds individual researchers of excellence in Europe, called the European Research Council. And then there is another one that is the applied research, the research relevant for society and science policy, that is carried out by DG Research, and where they put out calls for scientists to come together to address big societal challenges. And this has been really a very important tool to promote relevant science for society in Europe. And in the last few years, with the importance of the European Green Deal and the new European Biodiversity Strategy for 2030, there has been several calls, scientific calls, to ask scientists to help or assist the Commission in addressing a goal. And this one was a call on designing a new EU-wide framework for monitoring biodiversity. I was I was the lucky scientist to be able to get the consortium to win this call. These are competitive bids. And we presented the project to address this challenge that kind of follows the GeoBond playbook. And some of the aspects you're going to be seeing that are the same that are being done in AP-Bond. And the idea is that at the core of the approach is of this designing of an EU-wide framework for biodiversity monitoring is the essential biodiversity variable approach of GeoBond, where you use models to integrate different data streams from remote sensing to citizen science in these kind of multidimensional cubes that allow you to have continuous information on biodiversity in space and time and across taxa, from which you can derive different indicators. And we do this approach by focusing on engagement of stakeholders and user needs, by working with scientists in assessing what exists out there, by doing co-design of a new monitoring scheme, and by demonstrating this in a couple of showcases. So let me tell you a bit about this project and what we have done so far. So we are a consortium of 15 members across Europe, but besides the 15 institutions that are part of the consortium, we have established a network of members all over Europe that is open to anyone that wants to participate in the design of the European Biodiversity Monitoring System and in the future in its implementation. We have over 1,400 people all over Europe. And if you'd like to join, even being outside Europe to learn about the project, you can join in our website, europabond.org, and get all the information, the newsletters, be involved in stakeholder consultations, and play a role, of course, in implementing Europabond in the future, particularly if you are based in Europe. Now, the playbook that we are following is this idea of co-design of biodiversity observation networks with essential biodiversity variables developed by GeoBond. We just had a paper recently in Nature Ecology and Evolution, presenting this idea of the GBIOS, of this global biodiversity observation system. But this global biodiversity observation system really depends on having national or regional bonds that carry out the observations that are needed to do global assessments of biodiversity change. And to develop a biodiversity observation network, you really have four steps. You have to engage with stakeholders, you have to assess what is needed and what exists, what you have to design the observation system, and you have to implement it. And that's what we are doing in EuropaBond. We are doing these first three steps, engagement, assessment, and design. And we are also showcasing a few cases of implementation. I'm going to show you in a moment. And the key aspect of it is this idea of essential biodiversity variables. So to understand the concept, essential biodiversity variables is really a dual concept. It's about choosing the variables that are important to monitor, distributed across different dimensions of biodiversity. It goes from genetic diversity to ecosystem function. But then the idea that you have to combine, this is the duality of the concept. It's not only about the choice of the variables, but it's how you design the monitoring system to monitor those variables. And you can see that you have here in this diagram, we have some in situ observations in the top left. And you never have observations of everything everywhere. Most of the space and time is empty. And so you have only a few observations of biodiversity in the land surface and sea surface of our planet. So how do you complement that to have continuous information on different aspects of biodiversity that you can analyze at different scales from the local to the global scale? Well, you need to have some predictors that you can, for instance, track through remote sensing. And you have to use models that that are calibrated with those in situ observations to produce these essential biodiversity variables that are continuous in space and time and across taxa. And this is what we are doing here in EuropaBond. We are designing a system through user engagement, through assessment, and through design that will implement this kind of workflows for a set of essential biodiversity variables. What are the questions that we have? Well, first, what are DBVs that are needed for each policy question? So we identify DBVs that need to be monitored. Second, what taxa and ecosystems do you need to monitor? What is the spatial and temporal resolution of each EBV? And finally, the final question is how to design the sampling and what models to use for the different workflows. This is a project work plan. We are a 3-year project. We are close to the end. We started with the user needs assessment. We did an inventory of monitoring initiatives. We selected the essential biodiversity variables we wanted to monitor. We identified gaps in existing monitoring systems. And now we are preparing a plan for implementation of a biodiversity observation network, and also preparing to mobilize some examples of implementations into a data portal. And finally, we'd like to conclude with the terms of reference for the European Biodiversity Monitoring Center. So I'll just go very briefly through the main results that we had so far. All of the results are available publicly as a real collection. So if you go to the EuropaBond website and you follow there the link to the deliverables of the project, all of them are publicly available, so you can learn, you can consult them calmly whenever you want. Well, the first thing we did was a user assessment. So we did we worked with interviews and surveys involving over 200 users of biodiversity data across Europe to try to understand how they use biodiversity data on the policy cycle, on different steps of the policy cycle. And what did we find in this user assessment? Well, first we tried to understand how the biodiversity data was being used and what kind of policies and management decisions were requiring biodiversity data. And of course, not surprisingly, a lot of the biodiversity monitoring schemes are used to inform conservation actions at the species and protected area level across Europe. We tried to identify what were the main challenges of biodiversity regarding biodiversity monitoring in Europe. And the main challenges cluster around, let's say, 4 issues: the insufficient resources, financial, human capacity, the lack of integrated data. Sometimes the data is out there, but it's not easy to analyze, it's not integrated. And lack of sufficient data. So maybe the data is not sufficient because there is insufficient spatial coverage, or the monitoring frequency is too low to detect trends, or there is difficulty in accessing the raw data. And then insufficient taxonomic coverage, where only some taxa are covered. So there is bias in the data. And all of these challenges show up in different countries in Europe, but let's say the distribution of the challenge is not equal across. Some of the challenges are more important, let's say, in Western Europe than in Southern or Northern Europe. What we did also with this report, we're starting a process to select what variables should be monitored. And this was a process, a very participative process with several iterations, where we asked policymakers and the user to identify what were the questions that they needed to address with the biodiversity data, and to identify what will be the variables important for addressing those questions together with experts. And this resulted in a list of around 70 variables to be monitored. That's 70, so it's not a small number. But you have to also realize that this is across terrestrial, freshwater, marine ecosystems, and across different levels, from genetic level to ecosystem function. You can check all these EVVs on GitHub. We have this publicly available, so you can see what are these 70 variables. But they really group into 3 types of variables. There is a group of variables about monitoring the conservation status of species. There is another group of variables monitoring the ecosystem status and condition. And finally, there is some variables related to ecosystem services and ecosystem risks. So what we did next was to assess how is existing biodiversity monitoring in Europe for these variables. Do we have enough monitoring of these variables? So we built a database that shows how the data is integrated from different sites to the national level to the European level. And again, you can consult the database on the web. And then we analyze this database to look at the current status of monitoring of UBVs. And the status is not very good. For instance, for genetic composition, we had several criteria for assessing the status, from the level of spatial coverage to the level of sampling frequency to the availability of the data. Genetic composition, we're doing very poorly all across Europe. And for the best one, let's say the one that we have maybe some more data, are ecosystem structure and function, but still with certain important gaps across Europe. And this happens in all countries across Europe. So some countries are doing better, they have more variables monitored, but all countries are not monitoring some of the variables. Most countries are not monitoring many of the variables that are important. We also looked at what are the limitations in the current workflows, and we found that there is several aspects related to an integration of the data that is limiting the availability of biodiversity data. So data integration, that is one of the aspects here that we analyzed, is really a really big issue for biodiversity monitoring currently in Europe and in reality elsewhere. So what are we doing next? Now that we know what are the important variables to monitor, we know that a lot of them are not being monitored, and we know some are being monitored. We need now to, for these gaps, to design new monitoring schemes. And that's what we are working now on, is on designing these monitoring schemes with three components. What needs to be done in terms of data collection, what needs to be done in terms of data integration. Remember that data integration was the big bottleneck in our analysis. And what needs to be done in terms of monitoring, in terms of modeling. And broadly, we have already identified two types of EBVs. One that can be done by remote sensing. Of the 70 EBVs that we have, around one third can be reasonably done just from remote sensing, but 2/3 require some form of in situ observation, being either structured monitoring programs by scientists, citizen science observations, or some kind of novel technologies like eDNA. And for those, we have also identified candidates that are so poorly monitored now that if we would establish a network of European sites monitoring those EBVs, we'll fill a lot of the gaps in the information. And so now we are proposing not only that we need to monitor these EBVs, but where should we monitor some of these EBVs that are not currently monitored, by identifying a set of sites that should be monitored across Europe. So finally, besides doing all of this design that we are doing, what are the variables that should be monitored, where, how, we are also looking at what will you have as a result when you implement these monitoring schemes. And again, we cannot do, this is not a project for implementation of the monitoring system, so we can just do demonstrations. And we have some demonstrations in these showcases that we have done for different policies or different societal needs. And I'm just going to highlight one that is related to the societal value of monitoring. That is on monitoring the fructification phenology of mushrooms. And there we are working with a model that uses data observations from iNaturalist with environmental drivers like temperature and precipitation and projections of those for next few days to do your daily biodiversity forecast. And what we can do is tell people across Europe what is the likelihood of having these mushrooms out there fructifying to go and collect mushrooms. So you can, if you are a mushroom collector, you could go and see this biodiversity forecast to see where near your place you could go for mushroom harvesting in the next few days. So this is a demonstration of what can you do when you have the data and when you have the models, when you have the data integration to inform society about biodiversity. And we are mobilizing all of these data sets into a common portal called the GeoBon EBV portal. You can also check this portal in geobon.org. And this is my last slide. What would you like to have in the end of the project? Well, I would like that EuropaBon goes beyond the project and becomes a reality on the ground. And to make that happen, we are proposing that an European Biodiversity Monitoring Center should be installed to coordinate all the monitoring in Europe. And this European Biodiversity Monitoring Center would receive information from national monitoring programs, will coordinate and integrate information from those national monitoring programs, and also some European monitoring programs, and provide that information to the European Environmental Agency, to the European Commission, and to the CBD ultimately, through a platform like the Essential Biodiversity Variables Data Portal. And I must say that we are on a very good track to make this a reality, because the European Parliament, two of the committees of the European Parliament, the Environmental Committee and the Budget Committee, have just approved a pilot starting next year to implement such a European Biodiversity Monitoring Center. So it seems that something like this may happen in the future. Thank you for your attention.
Very much for your detailed presentation, Professor Pereira. Of course, you are lucky in Europe, it seems, with what you just said about the funding and the different commissions helping you in establishing the different projects that you have in front, that you have now done, and the one that will come on monitoring. We have, another thing that I wanted to mention is about the mushroom. Obviously, I will go there. I'm myself a mushroom picker, and I saw that my home country, Switzerland, was coming first with the chanterelle there. So we'll make sure I go at the right time next time I'm traveling there. We have now around 30 minutes left to address the questions that participants have asked online. And I will start with a question from Sherry Heshuk. Addressing human-wildlife concerns, the term coexistence refers to a state resulting from a suite of strategies that has successfully balanced the needs of wildlife and humans. These strategies include managing human use in designated wildlife habitats, excluding wildlife from developed areas, and biodiversity conservation. Can anyone please share any feedback on threatened species, and as well communities that are indicator species that can make a difference? Would anyone, either from CBD colleagues can answer as well, but from the panelists, can you see the questions, or should I read it again?
I'm happy to say a few words here, as we have recently in Europe a good example of the challenge of coexistence. So in a way, some landscapes in Europe can be an example of coexistence, but I wouldn't even say that Europe is the best example of coexistence. I think we have much better examples of coexistence between human and wildlife from elsewhere around the world, and Europe has a lot to learn. In reality, Europe has a lot to learn from other regions of the world. We do know that in some landscapes in Europe, we have been able to have relatively, I wouldn't say peaceful, but a relatively uneventful coexistence between the wolf and, for instance, shepherds. This is a big issue in Europe. Still, wolf was extinct in most of Europe until the late 19th century, until the late 20th century, until about 40, 50 years ago. And then it started returning around the 1970, 1980 to several regions that was not there before. For instance, the Alps, the wolf was completely extinct in the Alps. In Switzerland, there was no wolf, or in Germany, or in the Netherlands, or in many other regions. And it started colonizing, and now, for instance, in Germany, we have over 2,000 individuals of wolf, a species that was extinct about 20 years ago. It's now here. The question is, some have argued that you can have this coexistence between the wolf and the local communities, and that you can learn from a lot of the landscapes in Europe where this coexistence happens, where you have farmers, you have shepherds, and you have the wolf. And these landscapes happen in much of Italy, Spain, Portugal, all have these kind of landscapes. But in reality, it's become a hugely controversial topic. And just recently, the president of the Commission opened the process of consultation on this coexistence of people and wolf in Europe, because the wolf, there is concerns that the wolf is attacking too many livestock. And so in principle, we can say, well, yes, there is coexistence, there's landscapes where there is this coexistence. In reality, Europe could be seen as an example of coexistence. At the same time, the challenge exists that when you have wolf in your back door, and if you didn't have recent experience with the wolf, then all of these challenges come again to the forefront, and the coexistence may be hard to achieve for some. So the challenge is there, and I think I think Europe could learn a lot from other areas of the world where the coexistence with even more difficult predators happen. For instance, India, for instance, how India manages tiger populations. But there are many other examples where, for certainly, we could learn from the coexistence management from other areas of the world.
Professor Muraoka, would you like to respond as well from your region?
Yeah, thanks. Maybe already Henrique answered a lot, and I would just say something about that. Not only about the threatened species, maybe that we do have many various, right? I mean, wildlife, animals in our, for example, in Japan, many countryside cities or the area that humans are living are very much close to the mountains, rivers, and many other places. Like maybe you know the term Satoyama. So, so those mountains and the forests are very much close, and not only about cities, small cities in the countryside, but also the farmlands are very much close to those mountains. And this year we are learning many sad news cases that accident with the bears, because we don't know the real reason, but sometimes because maybe you know that the bear needs some acorns by the beach or other oak species, but in some years we don't have very good the acorns are limited. In that case, sometimes bears come to the urban, city or the some villages, towns. Then they have sometimes, or the farmlands, they try to have some crops from the humans cropland, and then sometimes we have some very sad accident. This could be also kind of a problem that we have to think about. Not all, sometimes we hear that the wildlife should be, of course, should be protected, and we don't have, we should not try to manage those wildlife. But for the local people, this is a kind of serious problem to try to coexist. So I don't have a clear answer, but maybe we need to have such kind of consideration when we think about some nature and the humans' activities or lives. Thanks.
Very much. We have another questions from Ivan Concea Alcolea. Since 1992, it goes around the presentation you've made with the timeline, Professor Herrera. Since 1992, political governments and financial actors levels are well aware of why CBD has been created, why Aichi, why post-2020, and the lengthy negotiated BBNG treaty. Also looking at climate treaties and COP now reaching number 28, the science has been more abundant and clear than ever, enough to know what to do or stop to do. The question, isn't it a problem of political leadership and accountability that biodiversity and environment are subchapter in the fights to win polls and financial support for campaign? That private sector voluntary pledges are more like magic thinking? Yeah, difficult questions, but does any one of you want to answer this?
Happy to start. Of course, political will maybe not one that we would like to have yet. And I think we need to strive to raise the societal and awareness and the politicians' awareness of the issue. But I would also not say that all the science is out there, that we have all the science for everything. In reality, I would say that there is very large gaps in our understanding of how biodiversity is changing and how we can address the drivers of biodiversity change. We have a lot of data and a lot of knowledge that should not delay action, so we can act now. But I do think that there are so many gaps that we need more. We need to continue to get more data, not only on what is happening, because one aspect is just getting the trends in biodiversity, but in what is driving those trends and what can be done to change those trends. So let's give an example. Protected areas. Okay, protected areas is one of the major tools that we have used to address the biodiversity crisis. And there is some strong scientific support for the effectiveness of protected areas. But recent studies have suggested that number one, a lot of biodiversity is not protected in protected areas. Protected areas don't cover all the biodiversity that needs protection. Number one. Number two, that even the species that are well covered by protected areas may have declines because protected areas are not islands. They live in landscapes surrounding them. And so even the effectiveness of protected areas for species that are well present in protected areas is variable. And it seems, for instance, it depends on the type of protected area. Different protected areas with different management types have different levels of effectiveness. And the science for doing all of this is these assessments is relatively recent. So how to improve the protection of biodiversity, where to place new protected areas. Okay, we have some science for that, but we didn't have so much science for that 20 years ago or 30 years ago. What type of protected areas should be implemented for what goals and where? Well, again, the science was not fully there a few years ago, and it's not completely fully there yet, but we have some answers. What other protection measures that are not based on science, so the non-site-based measures can you take? Well, we have, again, some ideas and some science, but the science really has been growing to support policy and continues to grow, and we continue to need this dialogue between science and policy.
And from AP Bond, Japan, yes, please.
Yeah, thank you very much. I just remember that a few years ago, 6 years ago, AP had its workshop at the one of the AOGO symposium, and we invited one scientist from Papua New Guinea. So he introduced his episode that he is trying to have more biodiversity observations and trying to connect with their local governments for biodiversity conservation. But he told us that he needs some more international cooperation to try to engage the local stakeholders in the regional or global context of the biodiversity change and why they need to conserve the biodiversity in Papua New Guinea or around Indonesia or Southeast Asia. So, and after a few years, just recently, we had an update from this person. After very good communication with the local stakeholders based on their biodiversity science data and knowledge, together with some inputs from the AP1 colleagues, they had a very good partnership with the local stakeholders, and some actions toward the conservation of biodiversity has been initiated. This could be a very good one example that the regional cooperation or international cooperation can support some local or some individual level activities in some countries in the region. And another example, for example, in Japan, that we have many professional biodiversity scientists, ecologists, or citizen scientists, or many citizens that are very much familiar with their nature. So local governments know that these are the very good movements for that. And after the Kunming-Montreal Global Biodiversity Framework was adopted in last December, in this last March, we have the Japanese biodiversity strategic plan to try to of course, contribute to the Kunming-Montreal and also to have the more conservation of biodiversity. Then this kind of national level policy would then come to the local governments in the prefecture scale. I mean, prefecture is something like state in the United States. Then these local governments should have a very good partnership with their local experts. Then the local museum or academia could have a very good partnership with those local governments. Then this kind of movements could have I don't know how much this kind of activities will impact some policy at the national level, but at least we have this kind of scheme. And then having this, learning from this scheme, then we go back to the regional cooperation. I mean, as lessons from Japan or lessons from New Guinea or lessons from other countries, we share these lessons with the other members in the local networks. Then we have the each national level kind of promotion, how to connect the biodiversity science with their local or national governments. But this is still the ongoing thought from the ABO. Thanks.
Thank you very much for those examples again. Here I'm moving to the chat with a question from Eri Tamale from the Secretariat. And he's asking, what are the requirements for one to join a national bond? I think you have answered already with the Europa bond, because this question was asked before you addressed this, but everyone can actually participate in the Europa bond, is it? And then maybe we hear from Japan as well and AP bond. Thank you.
Yeah, so at the individual level, anyone can participate. But I think the question may also be, how do you establish a national bond? And I think we need to go through these steps. We need to understand what are the users of such a biodiversity restoration network and what are the stakeholders. We need to assess what is needed, and then we need to design the bond. And so these steps that are well articulated in the documentation of GeoBond can be followed. And then if you want to be integrated in a regional or in a global bond, then you can just say, well, we organize this National Biodiversity Restoration Network, would like to be members of AP Bond, or I'd like to be members of Europa Bond, or I'd like to be members of GeoBond. That's the easy part. For GeoBond, for instance, just write a letter and ask for endorsement. It's very easy. The hard part is doing the National Biodiversity Restoration Network with the stakeholders, with the scientists, and doing the assessment of what is needed, doing the design, and so on. Yeah.
Yes, thank you. I agree with Henrique, what Henrique mentioned already. And for the AP bond, we always welcome that who want to participate in our monthly webinars or some other communications, cooperations. And because AP bond is a kind of group for the capacity building or community development in our region. So we actually, in our AP region, we only have a few national bonds that endorsed by Geo and offshore contributing to the Geo bond, but we are trying to connect the people who are interested in the biodiversity observations and also the conservation and also connection linkages with the stakeholders. So if you don't know if you know someone working for the biodiversity observation, and if he or she is connected with AP bond, you can access to the person. Or if you don't know anybody in your country, then if you can if you could contact me, then I will help you to connect with your future colleagues in your countries. Then we will support to develop your communities, and then that could be a very good future national bonds. Thanks.
Take the floor.
Yeah, no, thank you very much for the explanation. Actually, my question was mostly in the context of the national bond and trying to see, for example, if government officials who are in the ministries of responsible for the national biodiversity strategies or can be join the national bonds. Is it open to anybody who wants to join if one exists? And of course, as Henrique said, maybe in some cases they don't exist, and we have to figure out how a national bond can be established if it doesn't exist already. But in terms of membership, is it open to anybody who is interested to join a national bond? I think that was the context of my question, and more looking at how we can encourage more of the government officials that are working on this on biodiversity processes to join in order to gain, to get more first-hand information on what the bonds are doing and integrating it into the policy processes.
May I respond? One point that, for example, from the case of in AP bond, it is a kind of challenge in our region that not always the biodiversity scientists in certain countries are connected with the governments or ministries, because many scientists are doing their own research, but many of them are very much interested into delivering their data and knowledge into the national reporting or NVSAPs or some other conservation actions. So this is a challenge, but as I just briefly introduced in my presentation, AP bond is tightly linked with the Asia-Oceania Geo, which is the intergovernmental community under the Group on Earth Observations. So we have the national memberships in our region. So, and the AP bond is one of the long-running task group in Asia-Oceania Geo. So having using this scheme, we are hoping to help our colleagues of biodiversity scientists to engage with their national governments or the ministries related to the biodiversity or some environmental science policies. This is the kind of still ongoing activities, but we are doing that effort. Thank you.
Great, thank you.
Want to follow up, or is it okay?
No, it's fine. Thank you.
It's okay. Excellent. I think we have responded to most of the questions. You have responded online as well to a question related to what was it? Sorry.
Presentation.
Yeah, on the presentations. Yeah, the presentation will be made available. On this calibration issue as well was responded. The question was, I'm just putting it here. So the calibration component is essential, but it's subject to bias if the in situ observations are not truly random samples. And I'm reading the answer from Henrique, where he acknowledged that this is indeed an issue. And one way is to try to include the biases of opportunistic sampling itself. We did that in the mushroom modeling. Then we have another question, and I think this was answered as well. We will always have imperfect information. My impression, that's for Melody Green. My impression is what we need urgently is useful information that is relevant enough and reliable enough to support good decision making and to guide investment decisions. Do you feel enough attention has been given to connecting with data clients who will use information to guide action on the ground? And I will stop here and read Henrique's answer for those who didn't read it. This is a great point. How to identify what useful information is and to provide such information. I think this is what we try to do with the bond design. And yes, I remember from your presentation, you have made an assessment of this and the EBV approach. But certainly there is a lot to think about here. Is there anything from my colleague?
There is another question in the chat, in the Q&A. Is there a difference between a bond, national bond, and the CBD clearinghouse mechanism? I see Henrique is typing, but maybe you can answer.
I was trying to type here an answer to that. I've been monitoring the questions, and the CBD clearinghouse mechanism is something proposed by the CBD to somehow have all the information available on CBD topics and to share those. And I think having a biodiversity observation network, a national biodiversity observation network, may be a way of implementing such clearinghouse mechanism. They are not the same thing, but it's possible that you could implement a national clearinghouse mechanism by a national bond and a global clearinghouse mechanism through the global biodiversity observation system. Yeah.
I see you put on your camera. Would you like to complement or?
If I may add to that, I think this is very important. It's a very pertinent question because I think for most of our CBD colleagues, they work in the context of the clearinghouse, and these are the bonds and other kind of processes or initiatives should be able to feed into the national clearinghouse mechanism, and we need to think of how we can make that happen. And from what I heard from Hiroyuki, I think it's a good attempt from your side to see already how members of the national bonds or even the up bond in that case could work towards aligning with the national processes and feeding into the national processes. And the clearinghouse mechanism is one of those. So, yeah.
My colleague Abhinav, or is it okay? Okay, great. So I think we are nearing the time of the close of this webinar. First of all, I would like to thank our presenters today. Hiroyuki, you had to stay late, and Professor and Henrique, you had to leave a lesson that you were giving to your students. So please tell them a big thank you for your time. And I hope they can still, or they were maybe able to listen to this, or they can listen to this information later if this is relevant to your to the topic that you were addressing with your students. So thank you very much.
Thank you. Thank you for having me.
And just to tell you that in the next webinar on 21st of October, we will hear from two parties that have successfully transformed their institutions into learning organizations. This will be the 8th webinar in the series. Thank you very much, dear participants. This ends today's Knowledge Management for Biodiversity webinar. We thank you for your participation, for your very nice and valuable questions that you have asked online. We wish you all a very nice week and see you maybe next week. Thank you and bye-bye.
Thank you. Bye-bye.
Thank you, everyone.
Bye-bye.
Bye-bye.
Good day, everyone.